What is the maximum area of a rectangle that can be inscribed in a semicircle of radius 2? Okay, semicircle, a half circle, I'll say radius 2, and a rectangle. Okay? So, don't really know where to start. So I'm going to start writing up equations. So we know we want to do an area, and we want to maximize it. So we'll want it in terms of probably one variable, let's say x, and then we'll want to take the derivative of that. But for right now, we have it in terms of x and y. So we'll try and write y in terms of x. So basically we're saying that this y here will be something like y of x. So we want to use another equation, that for a circle. So we know that x squared plus y squared equals radius squared, which in this case is 4. So equation for a circle, x squared plus y squared equals r squared. And in this case, we're told that the radius is 2. Therefore, radius squared will be 4. And this will be our second equation. And we'll solve for y squared equals 4 minus x squared. Y equals 4 minus x squared square rooted. Okay? And then, therefore, we can rewrite area in terms of x. So we still have our same x right here. X times 4 minus x squared square rooted. We could probably even distribute this x, which I'm going to go for. So we write something like this. So we'd have x is the same as x squared square rooted. And now we can move it into or under the radical. So we have 4x squared minus x to the 4th square rooted. Okay? Now we didn't have to do that to take the derivative. We could have just looked at this and been like, all right, product rule. But what I did is I basically just cut a step out. So minus x to the 4th squared 1/2. Okay. Let's go to green. So a prime of x will be 1/2 4x squared minus x to the 4th to the negative 1/2 times, now we're going to have to do the chain rule, which will be the derivative of the interior. So we'll have 8x minus 4x cubed, which equals, we'll set equal to 0. And the idea is when we set the derivative equal to 0, we're finding maximum and minimums. And this is how we're going to optimize x. Let's see, what are we doing here? I'm going to backtrack just a little bit. Ideally, don't backtrack. Ideally, you get everything right the first time. Alas, I'm not that type of person. So here, I said area equals xy, which is kind of true. But what I'm finding then is this area right there, which isn't bad. But so what I can do, which I'm going to do, is maximize the area of this box here on the right. And then when I go to find the total area, let's see, yep, total area, I will double it. So I'll have 2 a's. And it's easier, I think, to find the area on the right. It doesn't really matter. I could have said a of x equals 2xy, and that would have been given me the same kind of answer. But since the left and right side are symmetrical, I can just do area equals xy. If I went back and did this over again, I'd probably say area equals 2xy, just to show that we have x here, and y there. But since I've already so far down this path, I'm going to keep going, and then I'll just double my answer at the end, because I'll have 2 boxes. So if I maximize the box on the right, it'll still maximize the total area of the rectangle. Okay. Back to finding the derivative, setting it equal to 0. I don't like orange. I don't know why. It's just, I don't know. It's a little bit harsh. It's a very bright color. There's nothing wrong with being bright, but I don't know. Okay, so we have, so the negative here means it's on the bottom denominator. 4x squared minus x to the fourth, check. 2, yep. And so the way we're going to solve this is multiply both sides by that. So one thing we have to be careful of is 4x squared minus x to the fourth cannot equal 0. Which means that 4x squared cannot equal x to the fourth, which means that 4 cannot equal x squared. X cannot equal 2? Well, that doesn't seem right at all. We'll check back on that later. But that is something to keep in mind. Interesting. Okay. Because the idea here is we can't have a 0 in the denominator. Interesting. So what we'll do is we'll end up going back to the original equation and seeing if it works or not. Okay. So then we have 8x minus 4x cubed equals 0. 8x equals 4x cubed. So we have x equals 0, because x could equal 0, and then both, it'd be true. It would be kind of trivial, I guess. Is that the term? Not exciting. 2 equals x squared. X equals square root of 2. Maybe. Okay, we'll go back up here, take a look at what we got, what we have as potential answers. So if x equals the square root of 2, so we have x equals 0 or x equals square root of 2, x cannot equal 2. Okay, so if we have, let's see here. X squared plus y squared, I'm looking at the circle now, equals 4, because r squared. Then we have 2 plus y squared equals 4. Okay. 2, so then we have y squared equals 2, because we subtract 2 from both sides. And then we have y equals also the square root of 2. So if we plug in x equals 0, and look at this, and we're like, okay, we're just going to have a straight up and down rectangle, which will give us a area of 0. Because if x is 0, then x times y will also be 0. If x equals 2, which we know it can't, but even if it did, then we'd have something that had 0 height. Y would be 0, but x would be 2, which it can't equal, but that's still it's not going to be our solution. So the solution that we got that looked reasonable was square root of 2. So we'd have square root of 2, square root of 2, and square root of 2. So our final answer would be square root of 2 times square root of 2 times square root of 2 times 2. Yes. So if you look at this, this would be 2 square root of 2, which would be x. And then we'd have square root of 2, which would be y. And we know that our area total would equal 2 times xy, which would be 2 times square root of 2, which would be 2 times 2, which would be 4. So our answer would be 4. Look at see what it's even a possible answer, which is nice. Ooh, that felt messier than it needed to be. That work is terrible. Horrendous. Okay. So, backtrack, big picture. What's the maximum area of the rectangle inside the circle? So we wrote out an equation for the rectangle. I messed up and wrote xy. Should have been 2xy. But I kept a note that I messed up. I was going to fix it later. So if I maximize this area over here, this right triangle, right square. Then I also have the equation x squared plus y squared equals r squared. I combine them to one equation with one variable. I take the derivative of that one equation, one variable, right here. And then I set that equation equal to 0. And that will find the maximum or minimum for that equation for the original area of x. I then took the critical points, which is what happens when you set the derivative equal to 0. Critical points are 0 and square root of 2, which are potential maximum or minimums. I also kept an eye on things that x couldn't be. In this case, we got x cannot equal 2. And then I looked at the original equation, looked at 0, 2, and square root of 2. And then square root of 2 would be the maximum. Plug that square root of 2 back into my original equation, and then remembering to multiply by 2. And I got an area of 4. So the maximum area here would be 4.